Namaste, this is JV and Dr. Vishal Saxena, Associate Professor in Mathematics in Jayoti Vidyapeeth, Women's University, Jaipur. Today I am going to discuss on the module Method of Solution, Graphical Method. This session is a part of the course Operation Research and under the program of BBA 6th semester and BBA LLB 6th semester of the university. The today's session is about the solving method of linear programming problem by the graphical method. As all we know that the linear programming problems are very important problems and it is a model. It can be taken as a model for the operation research and it finds various applications in different fields and this model of linear programming problems is included in various courses, various programs of the universities at UG and PG level and even at the higher level. The today's topic is concerned about the solution method of the linear programming problem by graphical method. As all we know that the another method by which we can solve the linear programming problem is the simplex method and both methods, simplex method and the graphical methods are good and this graphical method of solving linear programming problem will be based on the concept of the feasible region. Linear programming problems can be understood as the problems where the just a function is to be optimized and this must be in the linear form and along with various constraints and these constraints also in the linear form, maybe in equality or in the inequality form, as well as some non-negative restrictions are there, non-negative conditions will be there and graphical method will help to solve these such type of problems by the graphical way. And that's why just it will be depend on the feasible region concept. So first we draw the graphs for the constraints. If constraints are in equation form, in inequality form, then first we have to convert them into just these will be considered as in the equation form, then these can be just drawn as a line and next the feasible region will be taken, will be drawn for these constants and along with the non-negative conditions. And when the feasible region is obtained, then the extreme points on this feasible region will be just taken, will be calculated and next the objective function will be calculated on these extreme points. If that point on which the objective function is maximum or minimum, means the optimum value is there, that is called the optimum value of objective function, and that point, that extreme point will be called the optimal solution of the problem. So now we are having some slides to explain this topic with example. So we come to that, come to these slides and discuss on these. Now here the graphical method is explained that and we have already explained that the graphical method for solving the linear programming problems and here the concept of the feasible region is very important and this can be determined by all the constraints including non-negative constants say x comma y greater than or equal to 0 of linear programming problem. Then each point in the feasible region represents the feasible solution of the constraints and therefore it is called the solution feasible region for the problem, and the region apart from outside the feasible region is called as infeasible region. The optimal value, maximum and the minimum value obtained of an objective function in the feasible region at any point is called the optimal solution, and in this way we can find out the solution of this solution by this method. So how can we solve a problem by the graphical method? So these are the few steps to solve the problem. First of all, taking each inequation as an equation and graph them. So first we have to take the inequalities into the form of equalities and then graph them. Second point is find the feasible region for each constraint and the common feasible region. Next we have to find the common feasible region by all the constraints and with the non-negative conditions. And the third point is that find all the extreme points of the feasible region and the value of the objective function at these extreme points. And when the value of the objective function at these extreme points will be then it will show which point is the solution for our problem, and in this way we can conclude our result. Now we have this example to explain for the graphical method to solve this problem by graphical method. Here the objective function is to maximize z 4x plus 3y 4x plus 5y. So maximize z is equal to 4x plus 5y, and subject to the two constraints are given that 2x plus y is less than or equal to 9 and x plus y is less than or equal to 7 and x comma y greater than or equal to 0. Next now we will find out just first of all how can we solve these problem. So first we take these two constants as the equations, these two inequations as equations, like 2x plus y equal to 9 and x plus y is equal to 7. These are taken in the equation form because just we have to draw the graph of these two just inequalities, and therefore we can see here the two lines are shown here. So these two lines are just representing the two inequalities, the two equalities taking by the inequalities. Now here, so and what are the non-negative restrictions? What is the non-negative condition? The non-negative condition is that x greater than to 0 and y greater than to 0. So it means the feasible region bounded by the non-negative restrictions and these straight lines obtained by the constraints will be here shaded. This shaded portion is there, and that is the that is the feasible region. And now we can see the feasible region here is given by O, A, C, E, O. So O, A, C, E, O is the feasible region, and these are the extreme points of this feasible region, O, A, C, E. So these are the feasible these are the just points, extreme points for this feasible region. And now we have to find the value of objective functions on these extreme points. So here just the objective function at first point 0 comma 0 is 0. The objective function on the second point that means 9 by 2 comma 0 is equal to 18, and the objective function z at this point 2 comma 5 is equal to 33, and the objective function at this next point 0 comma 7 will be 35. So in this way the values of objective functions are obtained on these points, and these are 0, 18, 33 and 35. And now we can see which is the maximum objective function value, which is the value of objective function, and which is the maximum value, that is 35. So therefore the optimum value, the maximum value of Z is 35, and this is corresponding to the point 0 comma 7. So that is just the solution of this given LPP by the graphical method, and optimum point, that is optimum point is 0 comma 7, and the optimum value of Z is 35. So this is the problem solved by the graphical method, and now we can see in the same way we can solve the various problems of linear programming problems by the graphical method. It is a very good method, and just without calculations we can solve the linear programming problems with the concept of feasibility. So feasibility means first we have to draw the graphs of these inequalities, these inequations, and then the next task is that to just find the feasible region bounded by the feasible region of all these inequations, the constraints and the non-negative conditions. So in this way just the feasible region will be obtained, and extreme points will be obtained, and the solution can be just obtained by the taking extreme points on this feasible region, and one of the point will give us the optimum value of objective function on that. So this is the method of solution of linear programming problem. And besides this, one different method of solving the linear programming problem is the simplex method, and simplex method is another method by which we can solve the problem, and by that just we can solve the various difficult problems as well for the linear programming problems. So with this I conclude my today's session. Thank you.